In this video I will show how to make a siren with a microbit. The siren emits sounds as we know them from emergency vehicles. The pitch is controlled by the voltage to which P1 is exposed. We will use a program that looks like this. It reads the voltage on P1 and converts it to periods between 2000 and 1000 microseconds, corresponding to a frequency between 500 Hz and 1000 Hz. We can put these conversions into a table like this, and we will look more closely at the calculations. We start by calculating how long one period takes when, for example, the frequency is 2000 Hz. 2000 periods take 1 second. One period therefore takes 1/2000th of a second. If we measure in milliseconds, we must multiply by 1000 and we get this fraction. But we would like to have the number in microseconds, so we multiply by 1000 once again and get this fraction. When we have reduced, we can see that each period takes 500 microseconds when the frequency is 2000 Hz. We can now set up this formula. Here is a table with some values of period, time and frequency. Now I will try to connect P1 to the siren, alternately to ground and 3 volts. As a diagram it looks like this. If I touch ground, I get the lowest frequency, namely 500 Hz. If I touch 3 volts, I get the highest frequency, namely 1000 Hz. Now we insert a 10 kilo-ohm potentiometer as a voltage divider. In the middle position, the 3 volts from the microbit will be divided equally so that there are 1.5 volts across ground and P1. If we turn the wiper completely down to ground, there will be 0 volts on P1, and if we turn completely the other way, there will be 3 volts on P1. Now we can change the frequency gradually between 500 Hz and 1000 Hz. The layout looks like this. Now we replace the potentiometer with a light-dependent resistor and a resistor of 100 kilo-ohms. The layout looks like this. When in shade, the LDR get a great resistance, so the voltage across P1 and ground will drop, so does the frequency. If you swap the LDR and the resistor, you will get the opposite effect. The next experiment is to make a potentiometer by using a piece of wet paper. The diagram looks like this. Now we need an extra microbit with a program that sends out slow square curves on P0. We call it a square wave generator. The 2 microbits must be connected in this way. Now the frequency changes as the square wave generator has a high or a low voltage on P0. A new variant is to connect a resistor of 1 kilo-ohms and a capacitor of 470 microfarads to the siren as shown here. When I connect the resistor to 3 volts on the microbit, the capacitor will gradually charge through the resistor. The voltage on P1 will therefore increase. If I connect to ground, the capacitor will discharge and the frequency will drop. Now we make the square wave generator charge and discharge the capacitor. The diagram looks like this. On an oscilloscope you can see that the curves become slimmer when the tone becomes higher, the period time becomes shorter.